Hello friends, myself Saurabh Sharma. I am coming with question number 3 of Pathfinder, Newton laws of motion. What the question is saying? The question is saying a rope of length L placed straight on a frictionless horizontal floor is pulled longitudinally by a force F from one of its end. Tensile force T developed in the rope at a distance x from the rear end varies with x as shown in the graph. This graph is given. In this graph, we can say that how the tension is varying with the length. So what can you certainly conclude about the density of the rope? It is uniform. It decreases with the distance x from the rear end. It increases with the distance x from the rear end. It is maximum in the middle and decreases towards the other end. So let's say what is the question. I want to give the clarification. So here this is the path, and in this ground one rope is placed and we apply the force F on this rope. So let the mass of the rope is capital M. So acceleration of the rope is F by capital M. So if you want to calculate a length if you want to calculate a tension at a distance x from the rear end at this point, what is the tension is acting? So for better understanding, I'd redraw this situation. This is the length, x length of the rope, and this rope is experience a tension T. So if I want to draw the tension, then we can say the tension on the rope at a distance x from rear end T is equal to, you can say that the mass, it is mx into a, because this is also going with an acceleration a. So what is the mass? So basically we can say that mass of the rope is lambda dx from 0 to x into a. A is, I already calculated, F by capital M. Understood my point? If we differentiating on both sides with respect to x, differentiating on both sides with respect to x, so this is comes dt over dx, which is equal to lambda f by m. So my dear friend, from this expression we can say that the slope of the tension versus position or length curve is depends on the linear mass density. So slope of tension versus length depends on linear mass density. Lambda. So as you see in this graph, continuously the slope is decreases. Suppose here the slope is like this. So at this point the slope is like this. So slope is continuously decreases. So from graph t versus x, slope of the curve is continuously decreases. Slope of curve decreases. If the slope of the curve is decreases, so we can say that the lambda is also decreases from rear end. So we can say that in this question, what is the correct option? So correct option is B. Why it is B? Because it is decreases lambda. Okay, we can't say this option because the lambda is slope is continuously decreases. So this option is also wrong. Thank you so much for watching this video.